This is going to sound like a math lesson, but this is actually chemistry. So when we try and take data in chemistry, we've been talking about density lately. So I have some mass data here and I have some volume data here. And in order to interpret it, I want to make a graph. So we're going to learn how to plot some points in this graph and how to draw a best fit curve or best fit line. So we're going to start by looking at this scale here. The vertical scale is my mass scale, so I should write that. Let's put mass right here. And my horizontal scale down here is my volume scale, which it says right there. And this axis is labeled with a 2 and a 4, but these marks right here are unlabeled. So we first have to figure out, what are these unlabeled points? Well, if we jump from 0 to 2, then halfway between there is going to be a 1. And then we can take a look at like these little tick marks in between there and say, well, what's halfway between a 1 and a 0? Well, that would be a 0.5. So we would go 0.5, 1, 1.5, 2, 2.5, and you get the picture. We can keep going up right like that. On the scale down here, it goes 0 to 20. Oh, wait a minute. Well, what's halfway between 0 and 20? That would be a 10. And then, well, what's halfway between 0 and 10? That would be a 5. So in this case, on the bottom, we're counting by 5s. 5, 10, 15, 20, 25, 30, 35, 40. So we've got a scale, and we kind of understand what that scale is at this point. Now let's take a look at plotting the points. So if I want to plot 5 and 56.5, I first have to come over to the mass scale and find 5. So this is my 5 on the mass scale, and I'm going to draw an imaginary line or a dotted line that comes out of that 5 right there. Okay. And because if I go straight across like this, all of these are masses that are 5. But I need a mass that's 5 while the volume is 56.5. So shoot, where's 56.5 down here? Well, if this is 40, this must be 50. So here's 50. This must be 55. Where's 56.5? I'm not really sure. But I can guess that it's somewhere like here. And it's perfectly fine to guess. That's what I'm asking you to do, to estimate where 56.5 might be. And so this is my estimate of where 56.5 would be. And I'm going to draw myself another dotted line, only this time going vertically like that. And wherever these 2 points intersect, that's going to be my data point right there. So that, if we were graphing it, or if we were in a math class, we would call that 56.5, 5.0. In a chem class, we're not so interested in what the name of that point is. We just want the point itself. Okay, let's do that again for 7.5 grams and 84.5 or 84.8 milliliters. So 7.5, we know that 7 is here because it's halfway between 6 and 8. And we know that each one of these is a 0.5. So 7.5 would be here on my scale. And I'm going to draw a dotted line across again. Like so. And I'm going to try and find 84.8 over here. I know this is 90 because it's halfway between 80 and 100. And I know that this is probably 85 because it's halfway between 80 and 90. So 84.8 is really close to 85. So I'm going to put it like really close to the 85 line, like so, and draw my dotted lines again. And wherever those 2 dotted lines intersect, I'm going to put a point. like so. So pause the video and give the point 9.2 and 104 a shot. Try and graph that point on your own. I'll wait a second, so pause it, and then we'll pick up again. Did you really wait? Give it a try. The only way you're truly going to learn this is if you give this a try on your own, and then you use this video to help see if you were right or not. So I'm going to get a little bit lazy here, and I'm going to stop drawing all the dotted lines. I'm going to look for 9.2, and I know that halfway between 8 and 10 is 9. And I know that this line is 9.5, so 9.2 is like a little below the middle there. And I know I don't need to draw my line in here because the 104 is going to be way over here somewhere. So I'm just going to put down my ruler. And I'm going to start drawing my dotted line out here somewhere, like so. And then I'm going to come down to the bottom and find 104. This is 110, which makes this 105, which means 104 is just before the 105. And I can just put my ruler down this time. I don't even need to draw that line. I can say, well, my point must be right there. Okay. Try the next 2 points on your own. All right, did you wind up with 2 points out here? We'll figure out in a second if your points were correct, because these points, if you look at them, they look like they belong on a straight line. So what I want to do now is to take my ruler and I want to put it down on the paper and try and find a line that will go through as many points as possible, and still leave me some points above the line and below the line. And this looks like a pretty good line there. I've got 1 point that's below the line, and 2 points that are below the line. So I probably could have done a little bit better job, and brought this line a little bit lower to try and get those lines on there. But for the most part, the 5 points actually fit on one line. Now this line is called a line of best fit, or a best fit line, because it's the line that represents those 5 points the best. It gives you a good idea of like the general trend of what the points are doing. So even though we didn't take a data point down here around, say, like 2 grams, we can kind of tell that if we had 2 grams, that it would have a volume of about like 23 milliliters. So we can use the graph, or the best fit line in this case, to try and do some estimation at a later date.